Okay, so for this lesson, with BC1, we're just talking about the building blocks of geometry being points, lines, and planes. And I've got some blocks here, so you can literally see, with geometry, when we have shapes like this, all these shapes are made up of, well, they're made up of a face, they're made up of an edge, they're made up of these points. So we have points, we have lines, and we have planes. So that's all this is about, points, lines, and planes, and kind of how to name them. And so we start off with what are called the undefined terms. And that's point, line, and plane. And they're undefined because it's impossible to define these point, lines, and planes without using words or phrases that themselves need definition. So we can't define point without using some other geometry term that's based on points, lines, and planes. So we say they're undefined. But we can still describe them. So we say that a point is a location. And the way we write it, if we want to use this symbol for it, it's a capital letter. So the symbol for it is really also the same as the diagram. Like if you have a point and you label it point P, well, you also write it in a sentence, point P. Okay, the dimensions, well, a point in space is just a location, but it doesn't have a length or a width. So we say that it has 0 dimensions. Okay, and then example of a point would just be like the corner of a room. All right, a line goes in both directions forever. And a line is really just an infinite set of points kind of all strung together so that you can't even see the points, you see them as one continuous line. So it goes in both directions forever as an infinite set of points. The notation for a line, well, let's draw one here. Okay, so if we say there's our line, the line is an infinite set of points. It has to go through at least 2 points to draw a line. So we say that's points A and B. So when we name it, we can say that it's line AB, like that. So AB with a little line above it, or you can also use the notation of like a lowercase letter. So you could say that it was line L. And usually that lowercase is cursive. Okay, the dimensions of a line, well, it doesn't have any width, but it does have length. So there's 1 dimension, and that's length. And an example of that would be just where a ceiling and a wall meet, kind of like this. Let's say here's a ceiling, here's a wall, they meet at a line. All right, a plane. A plane is a flat surface, and that extends in all directions. And so we'll draw one before we write the notation. When we draw a plane, usually we draw it kind of as a parallelogram to kind of add some perspective to it. So it looks like a flat surface. And when we name it, there's usually kind of an italicized capital letter in the corner, or there might be 3 points in the plane. So point A, point B, point C. So when we write the name, every time we use write a plane in a sentence, we're going to say plane M for the lower or the capital italicized letter, or we can say plane ABC. And all you need is 3 points. You don't need to write 4, even if there were 4. Well, the plane has 2 dimensions, it has length and width. Okay, so we say it has 2 dimensions, length and width. Okay, so an example of a plane is just a floor, the ceiling, or a wall. Except for those usually stop. A plane, by definition, goes on forever. Okay, so now we can move on to our defined terms. So they're defined because we can describe them using our undefined terms. We can actually define these. And a line segment is just part of a line. That's the idea. It's part of a line that consists of 2 endpoints and all the points in between them. So when we draw it, an endpoint or a line segment has endpoints on each end instead of arrows. And so if you're going to name that segment, you just write AB with a bar above it. So that's segment AB. A ray is just a part of a line consisting of 1 endpoint and then all points on the line that extend in one direction. So 1 endpoint and then it goes forever in one direction. That's a ray. and you name it just with a small ray above it. So there's ray AB. Oh, sorry, we didn't put our points here. So if the endpoint is A and it goes through B, then we have ray AB. Okay, opposite rays is just simply two rays going in opposite directions, starting from the same endpoint. So maybe we have A as our endpoint going in that direction, so we have ray AB, and in the opposite direction, we have ray AC. So when we name it with opposite rays, we're just describing two rays, ray AB and ray AC. All right, lines can be and planes can be. Lines can intersect, they can be perpendicular, they can be parallel, or they can be skew. So when we have lines that intersect, they cross at exactly one point, and that point is just called the point of intersection. Okay, so kind of draw off to the side because we're going to name it on the right. Okay, there's our two lines, and we can say line N and line M. All right, and we can put a point here saying they intersect at point T. So if we were to write it, line N intersects line M at T. All right, so the capital letter indicates that it's a point. The lowercase letters indicate that it's a line. So that's important. All right, our lines can intersect at a right angle, which forms 90 degrees. Okay, we call that perpendicular. So we're going to draw one vertical, one horizontal, although it doesn't have to be vertical and horizontal. They just have to meet at 90 degrees, and that's what the box means. So again, we can call that line L, line M. Now there's a symbol for perpendicular. In fact, let's use points for this one. Let's say it's AB and CD. And we can say AB, line AB, is perpendicular to line CD. So that upside down capital T means perpendicular, right angle. All right, parallel. Well, those are just two lines in the same plane that never cross, never intersect. And one good way to draw these parallel lines is just by drawing a cube. So you can start by drawing a square, kind of find its center and draw another square that's the same size, right? And then just join the vertices. Okay, well, this front face is a plane, and we've got a line going through these 2 points, and we've got a line going through those 2 points, and those two lines will never intersect, and they're in the same plane, so they're parallel. So again, let's label this point A, point B, point C, point D. Okay, and so we would say that line AB is parallel to line CD. Okay, and then the last case is that two lines could be skew. And if they're skew, that means they're in different planes, but they also never intersect. So the definition for parallel is not that they never intersect, it's that they're in the same plane and they never intersect. Because you'll see, we can draw a cube again, draw a square, a second square, join the vertices. Okay. Well, here we have a line going through those 2 points on this front face. But we also have a line going through those 2 points on a different face or a different plane. And those two lines will never intersect, at least three-dimensionally, so the lines are skew. All right. Planes are similar. I mean, they can intersect or they can not intersect and be parallel. So if they have two planes that are parallel, that just means they don't cross. And again, it's kind of helpful just to draw a box. Two rectangles that are the same size, join the vertices. And so this is called a rectangular prism or box. And this box has 6 faces. And we can say that this top face or this top plane and this bottom plane will never intersect, so they're parallel. Well, if the planes are perpendicular, that just means that they're going to cross at 90 degrees. If I'm going too fast, obviously you can pause it. So pause, rewind, and catch up. We'll draw a box again. Okay, and I hope you can see that in this case, the way I drew it anyway, that there's a lot of places where a plane is intersecting with another plane at 90 degrees. You know, this front face and this side form 90 degrees, right? They're intersecting each other at a 90-degree angle. So those are perpendicular planes. In the last case, I'm not going to make you draw this one because it can be difficult, but we can just have planes that cross, not necessarily at 90 degrees. So we have plane MNB, so we name it with 3 points. Plane MNB intersects plane ABP at, well, they intersect at that line. So we're going to say they intersect at line AB. All right, next page, page 6. Okay, we have these two terms, collinear and coplanar. Co just means joined with, right? So if you have points that are linear, that means they're straight. That just means we have 3 or more points that lie on the same line. That means they're collinear. So A, B, C. Okay, so those 3 points are collinear. Okay, or they could be not collinear or non-collinear. Just simply 3 points, not all on the same line. Pretty simple, but it's a vocabulary that you need to know. Things can be collinear or non-collinear. Okay, and then lastly, we have coplanar. Again, just means together with. Coplanar means on the same plane. So we have these points A, B, and C that are all on the same plane, so they're all coplanar. Or we can have points A, B, C, and again, on paper, you know, A, B, and C are on the same plane. 3-dimensionally, you can't tell if C is above or below this flat surface. So points that are in lines that do not lie in the same plane are non-coplanar. And our last little fact, or actually this is a fact, not necessarily a definition like the rest, is that it requires any 3 non-collinear points to make a plane. Okay, so the idea is determine whether each set of points determines a plane, circle yes or no. So we have points F, G, and H. Can you draw a plane, a unique plane, through those 3 points? Well, you can't because they're all collinear. And you can see because they're collinear, I could draw that plane. Or I could draw that plane. Right? There's an infinite number of planes that you could draw through those collinear points. It doesn't create a unique plane, as opposed to these three non-collinear points. Well, you can see if you connect them, it automatically creates this unique flat surface between them. And there's no other flat surface that you could create except for that one. So these three non-collinear points do determine a plane, and these three do not. All right, hopefully that all made sense. If not, you can obviously go back and rewind or catch up if I went too fast. And I'll see you in class on Friday. All right, thanks.